Okay, now we have sound. Thanks. That's my favorite mistake, is to forget to turn on the microphone. I am Steve6464. Welcome. Normally I would be, normally I do little building projects, such as the Lego thing in the background there. But today I thought we would measure air. After watching Raichi 5 Zeros and Where's Wally beat up Flatzoid on some of the dumb stuff he says, and one of the things was air doesn't have weight. Testing, yes, you're right. Hello. 1, 2, 3, 4. 1, 2, 3, 4. I hope that's better. So after Flatzoid said that air doesn't have weight, there's a real simple test you can do to find that out. So I got myself this scale here, and I'm going to get it set up so everybody can see nicely. Please, I hope the bouncing of the cameras don't make you too dizzy. So, yeah, I know it's out of focus. It's the camera. And let's get this one set up so we can see the whole thing here. And I think I will make this one a little smaller. That's a little better. And because of this, the cover, I can't get my balloon on the scale. I tried taking it off, but it would have broken it, so I needed to, I lost the, damn it, oh, here it is. So I need to jerry rig it. Let's turn it on. Okay. So to get it above the cover, simple toilet paper roll. Put my little tray and zero that out. Okay, let's get rid of that glare. I think, if I remember correctly, there we go. That's better than what I had. I'm not going to be able to get my balloon in under there when I blow it up. But it's good that we try. Okay. My balloon. Uninflated. Weighs Yeah, I know, organize myself. Probably would have been better with a script. 9.871 grams. Alright. Let's take this and blow this up. Just a little bigger than what I had for my short. So Jens, how did you find me? Was it through the short? Through Facebook? Just whereabouts in the world are you from? Me, myself, I'm from Northern Illinois. Alright, the hard part of putting the balloon on is finding its center of gravity. Let's see, that should balance nicely. Well, that's that just got lighter. What's going on here? Didn't do this for the the short I made. It behaved itself. Alright, that's pretty steady now. So that is 10.166 grams for a difference of 10.166 minus 9.871. Difference of, does that show? Difference of 0.295 grams. Northern Germany. Wow. Oh, on Discord. Who's Discord? I posted like on four different sites. So, yep, air and gas have weights. In the balloon under pressure here, there's no liquid, so Flatzoid, you're wrong again. Compressed gas does not turn into liquid. Alright. Set this aside. I have one more thing I want to do. And I want to find the volume of my balloon. And then divide that by the weight, and we can figure out the density. Okay. Excuse me. So, don't know. What I was trying to do before I logged on was get it set up so my screen would share. There's a website that will help you figure out the volume of an egg, of all the things. Alright. Maybe tip that up. Oh, let's just break things. Shit. Okay. I'm going to turn this one off. Open this up. So first thing they want is to know the radius around the equator this way. Get my measuring tape, my Sharpie, find the fattest part of the balloon. Gotta remember to do this so other people can see. Let me turn this off. Okay. So that's telling me fattest part of the balloon is 72 centimeters. Okay. Oh, I wanted to mark the equator. I'm gonna mark it here and here. All right, set this aside. Set my pen aside. So it's 72 centimeters. And we know circumference, we want the radius. We know circumference equals 2 pi r. Our circumference is 72 equals 2 times 3.145. Mr. Sensible. For some reason, I don't need this anymore either. For some reason he only allows me to post a link. Everyone else will allow the thumbnail to come up. So let's get an accurate pi reading. 3.141. Well, I was off. 1 times r. 2 times that is 282.6 times r equals 72. And of course I put my calculator away. Divide both sides by 6.282. So 72 divide 6.282 equals So the radius is 11.46 centimeters. Now comes the fun part. Yep, thank you. I got it. So now the website wants to know the radius from here to here, and then the radius from here to here. I don't have enough calculus to know how to figure that out, so we're going to wing it. What do I do with my tape? Got my quick squares. This way. This probably isn't the most accurate, but for today, it's fine. I'll off the page here a bit. Alright. So get rid of this. So it's this long at this point. Oops, I forgot to do something. This long at this point. And the equator is right here. Alright, the straight edge. So the whole balloon is 24.4 centimeters. Not that we need the whole length. What I want to do, draw a parallel line. I did kind of sort of practice this earlier in the week. But sloth and laziness seems to get the better of me. Okay. And I think I need more space. So from the equator to the back of the balloon is 13.2. And from the knot to the equator, even 11. How does what happens? How do 2 millimeters disappear? $13.2, 11, okay, 11 centimeters, 13.2 centimeters. Let's see if I can't get, oops, sorry, nope. Lower left, there it is. Turn this back on. Alright. So, let's see, can that be seen? Okay. Why isn't it? This is not on. There we go. Do this with one hand. So there's the field. You know what? Turn this one around and point up. And that's not working. So to say make a camera, see if I can adjust the exposure. There we go. Alright, this field they want the equator radius, which is 11.46, not 11.6. The B radius is from the equator to the back end, and that was 13.2, and the C radius is from the knot to the center, which is 11. And I know what this is going to tell me. It's going to tell me C and B can't be smaller than A. It did not. So our volume, the volume of the balloon is 132 cubic centimeters. And the weight of the balloon was 10.166. grams. So, what is the density? Maybe this is what I was also trying to look up before I went live. How to find density. How to find the density of an object. Measure the object's mass or weight in kilograms or grams. Measure the volume of the object in cubic meters, or cubic centimeters, or millimeters. Divide the mass by the volume. All right. So 6132 divided by 10.166 equals, you will have then the density of the object in grams centimeters cubed. So the air in the balloon is 603.19 grams per centimeter cubed. What that means, I don't know. Just something I wanted to do. Make this a little bit longer. But the main point is air has weight. What the hell is this? Go back to this. Alright. The main point of this was air has weight. Yeah, the balloon falls. What would fall faster? Oh, that's not in the vacuum, so it doesn't matter. Alright, well, short one today. If you enjoyed my company or want to give me a second chance, I'll be here next week every Sunday. I will continue my Lego project. And until then, be safe, have a good day, be a friend to someone who needs it. And the last thing I have to say is,
Look!
Look, an echo chamber of derp.
Derp, 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 derp.
Derp, 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 derp,
Perspective. Gravity is not a force.
Einstein based nuclear. Derp, 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 derp.
Jerp. 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 Jerp.
Dub, 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 dub.